Encryption means to convert data to a different format that would need a cryptographic key to be read. A cryptographic key is not a physical key, but acts in a similar way. A locked door cannot be accessed without a key. When encrypting data, you are locking the information so it cannot be read by someone without the secret key. The process of encryption is between a sender and receiver. The sender has data known as plain text because it can be read by anyone. A cryptographic key is used in an algorithm to convert the data into encrypted text. This can now not be read easily and it is sent to the intended receiver. Encrypted data is known as ciphertext. If anyone now was to intercept the message being sent to the receiver, they would need to use the cryptographic key to decode the message again. Once the receiver has the encrypted text, an algorithm is then used to decode and decrypt the message. The algorithm performs a calculation combining the encrypted data and the key so that the message can be converted back to plain text and so it can be understood. To help you understand how a cryptographic key works, I will show you one method of encryption using XOR logical operator, which takes the original data and the key to combine them to produce the ciphertext. Using the XOR table, by combining input A and input B, we'll give the following outputs. If I wanted to send 01010101 and my cryptic key is 00110011, I would then combine these to produce the encrypted output as shown here. So my ciphertext here would then output as 01100110. Now, to decrypt this message, the receiver would then use the ciphertext and the cryptic key to be able to read the original message, as shown here. But this example has been simplified to help you understand how encryption works. The data would be encrypted using the same shared key, and then ciphertext would be sent over the network as a string of binary data that does not make sense on its own. The second computer would decrypt the information using the shared key to unlock the meaning of the information. In the example that I have just mentioned, I have explained how shared key encryption works. Here, the key used to encrypt and decrypt a message is the same key. It is important to note that this key must be kept secret from everybody else. It is important to know about a second method of encryption known as public key encryption. This is different to shared key encryption, as here there are two types of cryptographic keys, a public and a private one. Here the sender will encrypt plain text using the recipient's public key, which everybody has access to. Once encrypted, the ciphertext will be sent to the recipient. The recipient will then decrypt the text using a different key that only they have access to. The two keys in this example are different. The public key here is openly distributed to anyone that wants to send data to the recipient, but the recipient must be the only person that has access to the private key used to decrypt the ciphertext.